just looking at the square root function. So y equals root f of x. Okay, so if I have a curve that looks like this, and this is y equals f of x, and see that goes through 4, minus 3, and minus 2. And I want to draw y equals root f of x. Okay, so step 1 is you need to actually restrict your domain on this. So you need to go, all right, what can't you square root? You can't square root a negative. Now, a negative f of x would be below the x-axis. So that means you cannot square root the f of x below the x-axis. So that means all of this curve here cannot be part of your function. And the first step is you get rid of it. So you've got to rub it out. So you have nothing from underneath the axis. So nothing here. So you rub out below the x-axis. Your second thing that you need to do is you need to look at the x-intercepts. Now what happens when f of x equals 0? That means you'd have the square root of f of x, or the square root of 0, which is 0. So that will just be definitely a point there. So the x-intercepts will just stay the same. The third thing is, what happens to the curve that's above the positive? So when f of x is above the x-axis, what happens there? So I want you to have a think about this curve. If you're looking at where y equals 1, let's just say that was 1 there. I know it's a little bit higher. But if you had where y equals 1, when you square root 1, you get 1. So the square root of f of x, if f of x is 1, square root 1 is 1. So what that will mean is it's same at 0. If you get a little point in there, say when f of x equals f of x, say f of x was a quarter, what's the square root of a quarter? The square root of a quarter is a half, so it actually gets bigger. So when you're here, inside here, it actually gets bigger. And then when you're square rooting these numbers, like 4, square root of 4 is 2. So if you've got this number and you square root it, you're going to get 2. So it's going to come down. So what happens is the curve actually gets flattened. Because when you're square rooting these bigger numbers, square root 1 you get 1, square root 0 you get 0, square root of fraction, like a quarter, it goes to a half. But if you square any numbers up here, like 9, it'll go down to 3. So, if you've got curve at 9, your curve will go down to 3. If you've got curve at 4, your curve will go down to 2. So it actually comes down here and the curve gets flattened. And that green curve is y equals root f of x. So let's just run through one example here now. We're going to I'll draw a polynomial, so it really shows you. And we're going to make that 3, and that's minus 4. Okay, 1, 2, 3, 4, 5, 6, that's minus 6. 1, 2, 3, 4, 5, 6, 7, so that's 7. So what happens is if it's below the axis, it doesn't exist. The square root of 0 is 0, so that's okay. Square root of 1 would be 1, so that's kind of where it's starting to turn. The big curve so if you've got a big curve, it'll get small. So see up the top here, if you look at this is big here. So they're big numbers. Even here, the 3 will go to root 3. So 3 goes to root 3. If you have a number right up here at 9, it'll go to root 9, so it gets smaller. So what will happen here, it will go through 1, but then it flattens and it will come down. The 3 goes down as well, it flattens. So it comes down like this and it flattens. You don't have to worry about the 1 so much, but you have to know the basic shape. So just one more. Okay. Let's just look at like that. So if that's f of x, then when you're drawing the other one, go to 0. Every part of the curve just gets flattened. It looks like that. That disappears, that disappears. So your curve's basically looking like that and like that, and that's y equals root f of x.